So we've already seen that these 5 solenoid coils ensures that the amperage keeps pace with the voltage as this capacitor instigates the rise of both overall due to the rise of frequency in that it is pressurized by these 4 diodes to do so, to raise its frequency. So as a consequence, the energy level goes up. But what, what's the word I'm looking for? What determines the proportional relationship between the voltage and the amperage is this resistor right here. That's why I keep it pegged at 1.67. You could raise it, and you would get more voltage, and you would get less amperage. Well, now I can't remember if you get less amperage. Ooh, let's try it. Let's see, where did I put it? Let's try that and see what happens. Alright, so let's lower this to 1. And let's see what kind of 100 milliseconds. Okay. Let's see. So what shall we measure? Let's measure. Well, yeah. Let's measure the buffer. The buffer is what we're looking at. I believe that's what it is. That this resistor here predetermines to what degree the amperage will be in proportion to the voltage as it rises among these coils. I think that's the purpose of the transfer coil, is to ensure that the amperage keeps pace with the voltage and determine what it shall be. That's the point. Oh, I have to collapse this. Whoops. No? How do I get it? Okay. I'm not sure I know what I'm doing here. I thought I knew. Let's try, let's see, that's buffer. So let's see, voltage. Enter an expression. Ooh, something's gone fluey on me. Uh-oh. Oh, well. Unplanned events occur. Let's see. That hamper our ability to satisfy our desires. Let's try that again. Usually that's what you do if something goes wrong like that. You wipe out the data file. And you try again. So this resistive load section over here is not just something nice that's thrown in for good measure. It actually is simply an extension. Oh my god, it's not working. Oh, that is weird. It won't even tell me what it is. Oh, that is bizarre. Now it'll tell me what it is. Huh? No, we already have it. It's C2. Oh, that's strange. It refuses to tell me what it is. Why is that? Alright, let's get rid of this. There's something wrong here. I call it buffer. It's 1 ohm of resistance, and it's giving me problems. Well, maybe 1 doesn't work. Okay, let's do 1.01 just for the hell of it and see how that works. Now this is breaking the simulator, see? It doesn't mean I'm getting any advantage if it doesn't give me an answer. That's interesting. I know I can't go less than 1, and apparently I can't even go to 1. I have to be above 1. It's a very narrow window. It's like 1 to 5 ohms. Oh my goodness, wow, it's not even that. Okay, let's try 2. Oh, good grief. I wanted to illustrate a point. What's the point if I can't simulate? That is bizarre. It's the one component I can't find out what's going on with it. It used to be okay. I don't know what's going on. I no longer... what's that expression from Romeo and Juliet? I no longer dare to stay. I no longer dare to stay. I no longer dare to stay. Oh my God. Wait a minute. There's something screwy going on here. There is something really screwy going on here. That never happened before. Oh, that is bizarre. Just when you want something to work for you. Oh, I think I know what it is. Possibly I have a conflict between 2 different softwares running at the same time. Could be. Alright. Quit. Sometimes you can't do 2 things at once. Oh, I changed something fundamentally in the system too. That could be it. Who knows what it is. Well, you get my point, even if I can't illustrate the point. But see, I wanted to verify that the overall power didn't compensate by giving us less amperage by raising the resistance. Oh my God. It is something I did in the paging of the system. I'm going to have to restart this video. Unbelievable. That is remarkable. Okay, well, that takes care of that. It looks like I should maybe turn off this screencast. Maybe that's what I should do. Alright. I made a mistake. I renamed this resistor buffer when it used to be called load 1. And microcap doesn't like a component being called buffer. Here I call it transformer, and buffer is merely text. When you call a component buffer in microcap, it fails to give you any results when you do a simulation. So I went back to calling it R1 because it's not a load, and I revalued it at 1 ohm because I found I could go as low as 500 milliohms without any problems. And what I was testing for was to see whether or not this regulates the amperage rise of the surge, and it does not. It's really these current coils that regulate the current relative to the voltage as the surge develops. You know, how many of these do you have? You can have the minimum of 2, but if you add more, you get more current relative to the voltage. And of course, having a wide spread between the voltage, a wide spread of self-inductance between the voltage coils, each voltage coil and each current coil also helps, of course. But the number of current coils is, of course, the easiest. Well, I better not say easiest. It's another way to regulate the amperage relative to the voltage in your rise, in the surge that you're creating. But this resistor doesn't play much of a role. What it does is it raises the voltage when you raise the resistance here. And let me show you what happens. Here at 1 ohm, we get a wattage of about 120 gigawatts in 100 millisecond duration of analysis. And notice how many of these peaks we have here. This is RMS, but this is the peaks indicating when the staccato wedges occur. When does the spark gap fire at each one of these peaks? So the frequency, you get a general idea of the frequency of the spark gaps firing per first 100 milliseconds at 1 ohm. So now let's go to 500 milliohms. The frequency is much higher and the wattage is lower. It's just slightly above 75, it might be 80, 85 gigawatts. And then we go to 2 ohms and it takes longer. Yeah, it takes longer. This is less than 20 milliseconds it starts firing. But here it doesn't fire until after maybe 50 milliseconds. And there's much wider gap between the firing of the spark gap. And we go higher, we're up to 150 gigawatts. Over at 1 ohm, we were at 120. So we raised it by 30 gigawatts. Sorry. Probably because, see, the only thing that's happening here is the voltage is rising. And it's rising because we allow the spark gap to fire less frequently. That makes sense, right? The spark gap is regulated by voltage buildup, and then it fires. So we're not gaining any amperage. We're gaining watts, but it's not amperage watts. It's voltage watts. Voltage dominating. So regulating this resistor to try to get more amps is a waste of time. You'll get more voltage, but you're not allowed to raise this a whole lot before the whole thing starts to go phooey on you. So there's really not a whole lot of wiggle room. The real wiggle room is to do what Tesla Motors does. They put in lots of parallel wires in the rotor of their motor. And this is what we have to do here. We have to add lots of more current coils if we want more current. It's amazing the ease, the facility with which you can add more current to what is blended in the transfer coil by adding more current coils. You just extend this thing out and add more current coils. And how big's a current coil? It's a teensy little thing, 2 microhenries, you know? It's not like you got to rewind another voltage coil at 1 henry. So it's an amazing property here if you want more amps. You know, you've already got your volts set, you know, your motor, you've got the volts you want, but you need more amps. So it's really not that hard to get more amps. And talk about free energy, because amps are usually the hardest thing to get. Voltage is the easiest thing to get. Just stick your wet finger out in a lightning storm and get struck by lightning. You know, get plenty of volts there. It's the amps that are hard to get. And this was the whole point of the Heaviside solution, was to get what is hard to get, to solve the Ferranti effect, which was getting the easy thing, all the volts, but no amps. So it's an amazing property of this circuit that it's not that hard to get what you want in whatever quantity you want it. All right, so we've covered all that, and don't use the word buffer when you when you name your components in microcap. Avoid the word buffer. It's a reserved word apparently. Yeah, there are such things as reserved words in software programs. You have to stay away from their use. All right, this was just a short video. I had to do this.